Because it's recording itself recording.
Yeah.
No, because it's like...
Yeah. And they're
Okay.
Self-recording itself.
It's record section.
Yeah.
Recordception.
Yep.
So if you play that way, you're like...
See, I am recording audio. Yes. Yes, I am. As far as getting the videos to y'all, when I'm recording lessons, I am putting them on Ember Learning Lab's YouTube channel, and I'm releasing them in a public format, not in unlisted. So you can get to them just by going straight to YouTube for one thing. But as far as like a regular place, something is broken on Moodle, and I don't know whether it's broken on YouTube or broken on Moodle. And so I may or may not be sharing them on Moodle. I will be, I'm going to make sure my notifications are set correctly. I will be sharing them on our little Discord server as well, for sure, because that's easy peasy. Make sense?
Yeah.
Again, you'd be able to get to them just by searching Ember Learning Labs on YouTube and going there. So you can always get to them that way. All right, solving systems of equations. How are we doing? How are we doing? I didn't actually assign any homework. I just said we were going to do some things, right? Is that correct? Okay, good.
But you amused me when you said good job when I said I did my homework on Friday.
Oh yeah, so smart.
I did my math homework and you're like, yay!
Good job. So proud. Well, you know, we can all accomplish something sometime.
I hadn't done anything.
Well, you know. Okay. So, what kind of shape will this be? It will definitely not be a parabola. It's just a regular line, right? This is a linear function, right? If I was to graph this, how would I graph it? What is that going to look like? What do I do to graph that, boys and girls?
The y-intercept is 2.
The y-intercept is 2, and that is exactly where you would start. Okay. Except that's not quite right, is it? -2. And then what would I do to graph that thing? The slope is 3, so how am I going to count that on the graph? I'm going to go which direction?
Up 3 over 1.
Up 3 over 1. Look at you knowing things. So smart. So proud. It's a good job. I know. They're all just logs on bumps. 1, 2, 3 over 1. That's beautiful. Then we grab out our handy dandy straight edge. We connect the dots. And we have a graph, right?
Yep.
That's beautiful. To continue this beautifulness, let's draw another one. Another line. Let's kick it up a notch and make you do a little work for it. So let's do 2x minus 4y equals, let's say, 6. It'd be funny if I wasn't really thinking right and accidentally made the same line twice, because that wasn't what I wanted to do for this time. But that's not what I want to do. So if I want to graph this guy, let me change from my rainbow to my galaxy. Hey, if I want to graph that thing, what do I need to do? Okay, move the 2x, which how do I do that?
Or you could divide the whole thing by 2.
Or you could divide the whole thing by 2 first. Which do we want to do?
Divide the whole thing by 2.
No.
I like smaller numbers.
Fight. Okay, so divide everything by 2. Okay, let's do that.
I have good ideas.
You brought her around to your way of thinking. Okay, so 2x divided by 2 is x, and then -4y divided by 2 is -2y, and 6 divided by 2 is what? 3. Beautiful. Okay, now what?
Move the x.
Okay, how are we going to move the x?
Add both sides.
Yeah, add negative x or subtract x, same thing. Working on that in my middle school class right now. That's quite the challenge. Subtracting is the same as adding a negative. But why? Because it is. Okay, maybe it doesn't go quite like that, but maybe that's how it goes in my head sometimes. All right, so we didn't touch the negative 2y, so we're going to bring down negative 2y.
Got more than one voice in your head talking to you. You might be a therapist, maybe.
You know, in my humble opinion, we should all, every single one of us, spend some time talking to a therapist sometimes. Counseling is a good thing.
Yeah.
Okay, plus 3. Right, now what?
Um,
2.
Divide by what?
1.
What?
Oh, no.
What's attached to the y? Negative 2.
Divide by negative 2.
It's going to be okay. All right, so this guy is going to be y equals 1/2 x minus 1 1/2, right?
Yeah, but yeah.
Yeah, but what? Are you trying to fight me right now? Okay, so to graph this thing, what am I going to do?
You're going to
Oh. We just did one. How am I going to graph this thing? Where are we going to start?
The slope is 1/2.
The slope is 1/2, but I don't think we should start at the slope is 1/2. Where should we actually start? The y-intercept. So we're going to put a dot where? Negative 1 1/2. So we're going to put a dot right there-ish, right? Now what?
Then we use slope. You go up 1 and to the right 2.
Up 1 and to the right 1, 2. That sounds great. Up 1 over 2. There it is. Beautiful. Grab our handy dandy straight edge, slap it on there, connect the dots, and draw us a line. So, believe it or not, this right here that we have just done is your first system of equations right there. When we're talking about a system of equations, that's what we're talking about. We're talking about 2 lines. Well, they don't have to be lines. Actually, you can do a system of a parabola and a line, right? Whatever else. Now, if we are wanting to solve this system of equations, what we're looking for as a solution is we're looking for this right here. This is, whoa, that's never going to be all that visible. Let's add something that's something simple. Okay, how about gray? All right, that is the solution to this system right there, where those 2 lines cross. That is what we're talking about when we're talking about a solution to a system of equations. Make sense so far? Okay. Now, there are 3 basic types of systems. Three types of systems. Systems. Okay. First type is a system that is consistent and independent. How you spell dent? Yep, I was right in my head. I don't know why I always want to put an A there. Consistent and independent. The second type of system that we're going to look at is one that is consistent and dependent. And then lastly is a system that is inconsistent. Okay. So we're going to draw three little sets of axes. Whoosh. Hello, you can do it. And then una más. And then the x-axis, or axes, I suppose. There. Beautiful, right? So a consistent and independent system is one like the one we had up above, where you have two, I should totally not do that. I should totally use my straight edge still. Two lines that cross, and they're two totally different lines. Right? Those are consistent and they are independent of one another. And the consistency, it basically means that they have a solution. The independent means that they're different, which actually gives that statement right there gives you a clue about what the next two are. So a system that would be consistent and dependent would be a system where one line is right here, and then the other line is right here. Let me do that again for the people playing along at home. Consistent and dependent is where we have one line right here, and then another line right here. So in other words, we have two lines, but they're the same line. So this guy over here, the consistent and independent one, has one solution. Can we see that on the screen? Yeah. Okay. And so the consistent and dependent, how many solutions does it have? How many times are those lines touching on the consistent and dependent? Infinite. So this has infinitely many solutions. Infinite solutions. So what do you think this one is going to be over here? Anybody have any guesses?
No solution.
It's going to have no solution. That's true. So what would be two lines that their system has no solution? We have any? What?
They don't meet at all.
They don't meet at all. What do we call two lines that don't meet at all that are on the same plane? Parallel. That's right. Parallel. Anybody ever watched Monk? The TV show?
So dumb.
It is great. Monk is wonderful. Have you seen the episode with the little dry cleaning lady? That with her parallel. My stitches are parallel. She's pretty hilarious. That show is hilarious.
Have you seen Psych?
I have definitely seen Psych. We've talked about it before. Do you have a little brother? Yeah. Yeah. Was he in that Floor's Lava class? I think he talked to me because he was asking me about Psych. So I think it was probably your brother. There's not a lot of people that just randomly ask, "Have you seen Psych?" It's probably your brother. I think I've met that kid before, but I didn't know until that moment that he was your brother.
The thing with Psych is it's either your favorite show
or you abhor it. Yes, that's probably true. Okay, so now what we have actually seen one method of solving systems. It's a crappy method, but it is a method. Okay, so we've actually already seen just today with this, if you want to call this an example up here, this would be an example of solving a system by graphing. Okay, now, and this right here is the last time you're ever going to solve a system by graphing, right there. Because the problem with solving a system with graphing is, what's the solution to this thing? What is this point right here? What is this gray point? Exactly. You don't know. It's like It's something along the lines of like 1/3 and -1 1/3. I don't know, something along those lines. Just look at it, right? It's like somewhere in there-ish, right? And this is math class. This isn't physics class where we can get a close solution and be fine with it. This is math class, and we want to be able to say it's right there. And even if it's some non-repeating decimal, something ugly, in math class, we want to say it's pi numbers, not 3.14159, etc. Right? We want to be able to say it's pi. We want to be able to say this is specifically exactly where it is. And that's, we can't do very well with graphic. Gosh, I got excited. I'm like spitting all over my computer. It's a good thing y'all are sitting way away. Okay. All right, so we're going to look at a few different methods to solve a system of equations. Times it. Yeah, we're going to get through at least one of these, maybe two.
Maybe all three.
We definitely won't get to doing ones where we solve it with matrices and such. We do that in this thing, don't we? Yes, we do. Okay, good. That is in this unit. It's going to be great. You're going to love it. Probably. Okay. If you had graphing calculators, you'd really love it, because then once we do it with matrices, you just punch it in and be like, enter. But that's okay. All right. Solving systems with substitution.
Still the same.
Yep. We're going to do solving by substitution. We're going to do solving by elimination in this lesson. Theoretically, solving by substitution should be reviewed, but it won't be. So we're going to take it slow and learn it for the first time. How's that sound?
Yeah.
Solving by substitution. Examples. We're going to learn bigger systems later, but for now we're just looking at 2x2 systems. We'll learn what that statement means later as well. Well, actually, we'll learn that statement right now, because why not? So these are all going to be 2x2. What that means is there are two variables. And in order to solve for two variables, we need two equations. Oh, what I'm writing? Two equations. Later, we're going to talk about 3x3 systems. Which if you have three variables, you need three equations. If we only have one variable, then we only need one equation, and that's just solving a regular equation like what we've been doing for a long time, right? What are you doing? Oh, that's funny. Only homeschoolers. Okay.
Over here, like Leroy Gibbs.
All right. So example one.
He would sharpen his nose.
Here's the system we're going to start with. Y equals -2/3. You know, we should have done the 2 that we already did. Maybe we'll do that as example 2. Y equals -2/3 x minus 1. And y equals 4x plus 5. Okay, so solving by substitution, we do what it sounds like we do. We take something and we substitute it for something else. So in this one, this very, very first example of solving by substitution, I made it really easy for us. Okay, because these are both already solved for y, right? So this equals y, and this equals y. So if they both equal y, then we can substitute in one for the other straight away. So what we're going to do is we're going to take that and we're going to plug it into there. Because that equals y, and so does that. Okay, so what that means is we're going to set up an equation now that is negative 2/3 x minus 1 equals 4x plus 5. Make sense so far? Now we just solve for x. So what would we do to solve this guy for x? Are we still recording? Yes, good. Hello. Go away. All right, what should we do now? I agree, that's a great idea. Any others?
So get x on one side.
Okay, so how? Give me something more specific. We've been doing this for a while. You know what I'm asking for.
Subtract 4.
Subtract 4x, right?
4x.
Yeah, that's what you meant. Of course it is. We're going to subtract 4x. And we're going to subtract 4x over here.
Wouldn't we want to have it over there on that side?
Well, you could.
Doesn't matter. Either way. You could do it either way.
We should.
Okay.
So what's negative 2/3 x minus 4x?
Negative 4 or 2 over 3.
Yeah, negative 4 2/3. Sounds right to me. Which for those of us playing along at home would be negative 14/3. In case you want to do things in your head instead of calculator. Now, minus 1 equals, we bring down the 5. Now what should we do?
Add 1 to both sides.
Add 1 to both sides sounds like a great idea. Ooh. Bring down what we haven't touched over there. So we've got negative 4 2/3 x equals 6. Sounds like a great idea. What should we do now?
Divide it by 4 and then use 6.
Negative, right?
Negative.
What am I writing? 4 2/3 divided by negative 4 2/3. Which would be the same thing as multiplying by negative 3 over 14. X equals what?
Negative 9 over 4.
Negative 2. Wait, just get 2 and.
What? Make sure that you put, if you're putting this in your, oh, that's not what I want. Make sure, I will want that later, but make sure that if you're putting this in your calculator as is, make sure that you put it in parentheses.
1 1/3.
What did you say? Well, you said 1 1/3. That doesn't sound right because it should be negative 9/7. Unless I did something wrong in my head, which is possible because I did a whole lot in my head.
It's got negative 1.
I also got negative 1. So no.
Good Lord. Make sure you're punching it in your calculator correctly.
I'm punching it.
I said correctly.
Okay.
So, what are you punching in your calculator, boys and girls?
6 divided by negative 4 divided by 2, 2 divided by 3, which is, but like in parentheses.
Did you add 4 plus 2/3? Because if you didn't, then it probably thought you were multiplying it.
Oh, wait, no.
Are you using a fraction button?
I did. I got negative 0.83.
Convert it back to a fraction for me.
-5/6. Who knows?
Feel like we're breaking our calculators. This is why we have to know what we're doing instead of just punching. Yes. Calculators are only a tool.
It's only as smart as the user.
So let's everybody rewind and let's make something that's easier to punch in your calculator, boys and girls. So let's rewind back to up here. So okay, so right here. Start with this. Punch that in your calculator. Use your fraction button. You've all got one, except one of you. Punch that in your calculator. Make it an improper fraction in your calculator. I think even can yours do? Did we decide yours can do an improper fraction? I don't remember.
No.
Does it convert between the two?
And then just -4.
Shouldn't be. You did something wrong, yeah?
I got yours.
Don't we have a fraction button? No.
Yeah, it's sweet potato.
Yeah, that's cheap, right? Yeah, oh yeah, fraction of decimal. Good. So 4. No, just kidding. 2 fraction 3. Okay. Negative minus 4. 4 and 2/3, and then we'll convert it to this for the lettuce. Yeah. Did you see how I did that?
Hold on.
It's second, and this one converts back and forth between fraction and mixed number. Okay. So everybody should, and if you can't get this on your calculator, you need to let me know what's going on. Do you have the same calculator as him?
No, I do.
No, don't y'all both have a calculator, or y'all sharing?
I thought it was in here. It is not. So
No, that's fine. Do you have the same type as him?
Sort of. His is a little different. He's got different buttons and stuff.
It's not different.
It's all the same word. It's all.
Oh, it's not the same. Oh, you have like a Casio or something? Okay. Because I was going to have you follow along with him, but.
I don't know.
I don't have a fraction.
Okay. You don't have a fraction button, but you kind of do. Okay, so what you need what I want you to be able to get in your calculator is that number. If you don't have that number in your calculator right now, then let me know and I'll help you get it.
I have 4
Negative
a lot.
14.
Negative 14/3. You have it?
I have -4 point a lot of 6.
Yeah. So we need to be able to convert to a fraction. You know how to do that?
14 divided by
I don't either, but we're going to figure it out together. It's going to be right there. FD. So second, enter. And then we should be able to do this again to get it into an improper. Do that one in order to get it into an improper. Yours is unfortunately a 2-step process, same as his, so you can show him yours.
Get to the fraction.
Yeah, you have
The math button.
yeah. So what are we doing? We're doing 2/3. 2.
That one just turns into
2 divided by 3. Add negative, huh? Insert negative. Following along at home. Negative 2/3 minus 4 equals that. And then we got to go, what did you say? Got to go math. And then convert to fraction. This is at least the top option.
Yeah.
Okay, good. So you got it? Y'all got it? You got it? Good.
No, I don't have it.
You don't have it.
Is that it?
Oh yeah, yours. Oh, that's a 0. No, that's not what we're looking for. Let's see.
So I did
Like Marshall Ramirez.
2 by 3.
Really?
Find it here.
There's different calculators.
She used the Casio for years, even though she told everybody to buy that calculator.
I don't
Oh,
know
it's not
how I
funny.
got mine.
It's like it costs $10. Just go buy them. Not you, but oh, here's the fountain. Okay, so when you push enter with that, that's fine. That's what we get. Okay, yeah. So what we want, aggregate. Let me go back. Okay, so what we're doing is we're subtracting the the negative 2/3 minus 1. That's how we're getting the number, right? So we're going to do you know how to put a fraction here? Have you figured that out yet? Because I just found it. Okay, good. So do that.
That's what I'm doing.
No, not that.
You
Why
always said
didn't you
the
know?
fractions is the same as the bite.
It is true. And if you're going to do that, and if you want to do it that way, do it that way. But this is what I need you to add to that process. If you do it that way, do you have a negative button or is it just a minus on the side? Just a minus. This. Negative.
Let's do it from here though.
And then put it in parentheses if you're going to do the division way. So just add that, and then
this one.
then you'll keep from having weirdness. And then minus 4, right? And so we're going to get that number. Now we don't want that number to be that number. What we want it to be is that number, whatever I wrote up on the board, right? And so this is what
I did
we
that.
have to
I
hit.
thought we were here, and I was like, I'm so
Shift.
Yeah.
And then we have to hit this one, and it'll turn it into a fraction. Yeah, I can see that's the whole proper fraction thing. Okay. All right, how are we doing? Everybody figured out how to get what's in the thing?
You got the thing.
Now, here's the next thing. Now, this next thing I have to tell you is really important. When you punch stuff in your calculator, don't hit clear. Leave it there. Leave it there because you may need it later. Because you should be able to do 5 plus 1 on your own without a calculator. Right? So then, now, everybody, I think, except maybe you, but that's okay. That's why I had you convert it to a mixed number, to an improper fraction, because that you can jot down without getting weird decimals.
It's a mixed number.
That's fine, or improper fraction, whatever. Doesn't matter, regardless, right? Because you can put both. You have a fraction button that you can put either that in there, right? Yeah. So you're still okay. It's okay. Take a breath. Okay. So everybody, I think, but you, because we decided we didn't have an answer button, right? Didn't we decide that doesn't exist on that calculator? There is an equals, okay? But everybody else should have a button that says either answer or ANS.
Yeah, I don't have that.
Yep.
Like
Enter is not the same, but your answer is probably by the enter.
Yes.
No,
Yeah.
negative.
You have the exact same calculator as this, so yeah, it's right above the minus.
Oh,
Yeah.
wait, hold on.
Yeah,
Right?
ours is also both minus.
Oh, yeah.
Yeah, yours is okay. So we have something along those lines. So here's what we need to do. So in your calculator right now, you should have negative 14 thirds.
Yep.
So what you can plug in now is you can say 6 divided by, and then second or shift or whatever you push, and then answer. And when you do that, you should get one of these two things.
I never realized that's what that was.
You push what?
Oh my goodness.
Answer 6 divided by that. Oh,
It's divided by AMs. Is
Answer divided by 6.
oh yeah, there it is.
no, 6 divided by answer.
I found it.
Good. Did it work out?
Yes.
Good.
Hey.
We did it.
Negative 1 point. No.
We're not.
Now hit your convert to a fraction button.
Negative 1 and 2%.
Good. The 2 over 7. Oh yeah, this one right there.
Oh yeah.
Whoa, that was not what I wanted. Come back. You don't need, and also, even after spending, because I do want you to be able to use your calculator well, right? And so that's why we took the time to do that. Because especially on a test, if you get stuck and you're like, I don't remember, how do I do this? Then just punch it in your calculator, right? That's fine. But if you will learn that to convert this to an improper fraction, you go back to middle school and you multiply and then add and do 4 times 3 equals 12 plus 2 is 14, which is that number.
Wouldn't it be a positive? Because
The whole number is negative. And the reason why that works out that way is because, well, whatever. But yeah, it's been the longest solving by substitution I've ever done in my life, but it's okay.
Wait, so I got some.
And that's what you.
I did everything that you said, and I got negative 1.28571.
So convert it to a fraction. You remember where that button is?
Yeah. How do you do that? At 9. I put that.
Yeah. Yours is right there, right that button right above the equals. You just push it. But it'll switch back and forth. Okay. Did you figure it out?
Yep.
Think we got with it.
Figured out.
Okay, so what I was saying is you don't really even need no stinking calculator because if we have negative 14 over 3 x equals 6, to get rid of a fraction, you multiply by the reciprocal. Because that cancels, and we get x equals, and then you can pre-reduce, right? What goes into 14 and 6? 2. 6 divided by 2 is 3. 14 divided by 2 is 7. X equals negative. 3 times 3 is 9/7. Which is faster, probably, than punching it in your calculator. So if you remember some of the basics, then you're also doing well. Okay? So, now, our answer to part of this problem is x equals negative 9/7, or negative 1 2/7, either one, right? Those are the same numbers. Now, we're not quite finished, right? Because we've solved for x, now we need to solve for y. So what's the last thing we need to do on this problem?
Plug that in.
Or either one. You plug it into one of them, right? All right. So we're going to take this guy and we're going to plug it into the one without a fraction. How about?
Yeah, let's do that.
Yeah,
Of course, we're plugging a fraction in, so whatevs, right? It would actually probably be just as easy either way on this problem. But in fact, actually, probably the other one is actually probably technically easier, but it's okay. Because this is what you would do. So, y equals 4 times negative 9/7. Improper fractions are always easier to work with because there's less buttons and there's less to do in your head and whatever else. So keeping it improper until possibly the end. And in this class, you don't even have to convert it back. This isn't middle school math. There are some college professors that even like calculus and whatever else they make you convert it, which I always found to be dumb. Okay, but it's fine. All right, so what's 4 times negative 9/7?
Negative 5.142.
Get rid of those dumb decimals. Decimals are a pain.
Negative 36.
Yeah, which you didn't even need a calculator for because you probably knew that 4 times 9 is 36, right?
Negative 5.1 over 7.
5.1 over 7. What? I'm confused now. So what is negative 36/7 plus 5?
5.1 over 7.
5 what? No, that's not. I don't know how you're making that happen in your calculator. You're magicking your calculator somehow. You can do that without a calculator too, y'all.
7 minus
Oops.
5.1.
5.1 over 7?
No, 5
and 1/7. That makes way more sense.
There's a line there. It looks like a dot.
Yeah, it's probably 5 and 1/7. That I could believe.
Oh, is that the right answer? Yes.
Yeah, I suppose you can't have a decimal to fraction.
Negative 36 over 7.
Disappointing.
5.1
Yeah, that's kind of what I thought.
5 equals 7. It's negative 36 over 7. Yes, and then plus 5 would be.
What's that one we're doing over there?
Which number doing over where, buddy?
It was 7.
Negative.
It's converting that to sevenths. It's the fact that you don't have to have a calculator to solve this problem. Make sure you're putting your fractions in parentheses. And make sure you're making this negative.
I got negative 1 over 7.
Why did I write 37? Why are y'all screaming at me? Stop it. Calm down.
Yeah.
Damn.
Yeah. So negative 1/7.
Yep.
So our answer, and we write our answer as an ordered pair. When we do 3 by 3 systems, we will write them as an ordered triple. Is negative 9/7. Negative 1/7.
That'd be y equals.
I missed
No,
the
no,
eyes.
y, that's
Yeah,
y,
that's
x, and y.
X and Y. That's right.
Man.
What's sir? Nothing.
I missed the imaginary numbers, those were easy. I understood them.
Yeah, I understand this
Good
too.
one.
There were only 1 of 4 answers, and
Yeah.
it was easy to find.
Let's do another one by substitution. I think we're going to split this lesson into 2 days. Either fortunately or unfortunately, that's what's going to happen. What? Yeah, you definitely have homework. Oh my gosh. You think you're going to have more than 1 day without homework?
Yes.
I know. You got to play. Life happens. It's okay.
Exactly.
Example. It did make sense. You just weren't following along.
You gotta play the game. It's life.
Okay, let's do 5x
You're ready to move out of game.
minus 3y equals 23. And 2x plus y equals 7. Although the fact that we are splitting this lesson into 2 days does mean you'll have less homework, but you will still have homework. Okay, so we are still solving by substitution. We haven't learned any other method yet. We will do that on Thursday, right? So in order, it depends on the thing. On this one, I would do a substitution, although a lot of people, once they learn elimination, they only ever use elimination. Although this one is definitely easier with substitution.
I just eliminate the entire thing and just
No. My answer is you.
All right, so in order to solve by substitution, we have to take either the first equation or the second equation, one of the two, and we have to solve it for one of the variables. So this one, for this problem, it's going to be easiest to take this one and solve it for y, right? Because y doesn't have any numbers on it. Does that make sense? So we're gonna maybe not even end up with any fractions, right? Okay, so to solve this second one for y, we would just subtract 2x, which is what you've been screaming over there the whole time, which is still correct, right? So minus 2x and then minus 2x. That's beautiful. This cancels, and so we end up with y equals 7 minus 2x. So now that equals y. So what we can do to solve with substitution is we can take this that equals y, and we can take it and substitute, name of the game, that for y up here.
Yay.
Yay. Okay. So we would rewrite that equation as 5x minus 3 times this guy that we're plugging in. So times 7 minus 2x. And then that equals 23, right? And then we're going to solve for x. So in order to solve for x, what are we going to do?
Let's first.
Yeah.
Yeah, kind of the parentheses first, but I need more words than that. Distribute. Perfect. So I'm going to distribute that -3. And so I'm going to bring down 5x because I haven't touched it. -3 times 7 is what?
-21.
-21. And then -3 times -2x is what?
-6. No, 6x.
6x. So plus 6x equals 23. What am I going to do now?
Do the
21
and
So yeah, because we're algebra 2 and we're pushing our time, we're going to do two things.
Cool.
We're going to combine like terms, and we're going to add 21 to both sides. How's that sound? Everybody following?
Nice.
What's 5x plus 6x? 11x. If you people choose to combine steps, make sure you write your intermediate steps and keep it neat.
Okay.
So
What's 23 plus 21? 44.
quick math.
Okay. Now what are we going to do? Divide by 11. So we have discovered now
Easy.
that x equals 4.
Yeah.
Okay. Now we're going to take and we're going to find y by taking and substituting this 4 into either equation.
Let's do the easiest.
What might be a really great idea is to take and substitute it right there because that one's already solved for y. How's that sound to y'all?
Because of the blue and the pink, this looks like a terrible gender reveal.
If you say so.
So you
Okay. So we're going to take it and do y equals 7 minus 2 times x, and we're going to plug 4 in for x, right? So what's -4 times 2? Or -2 times 4? Same difference. -8. So 7 minus 8 is what? It is -1. That's true. So our answer then is the ordered pair for -1.
Yeah.
Homework.
That was so much easier than the other one. That one was that one I actually got. The other one confused so much. Nobody else.
Yeah, that's what we're gonna do. That should have been the first one.
That was so much easier.
Yeah, but we wouldn't have gotten to learn all of that or practice all that calculator work. Pages 141 through 142. We're going to do numbers. This is going to be a little different than normal, kind of. We're going to do 14 through 18 evens. And then we're also going to do
We or us?
46 through 50 evens. And 51. That is your homeworks.
46.
Any questions? Well, with 2 minutes to spare, we're finished.